widely being used in the industry. But also the trick is, if I talk about interview questions, the trick problem will be you will not be allowed to use this built-in class. You will be said that implement your custom blocking queue. So you have to write something like blocking queue buffer equal to new custom blocking queue or my custom blocking queue implementation, something like that. In real world, we use blocking queue. Most of the questions are also centered around blocking queue, which is the higher level abstraction. Why is it a higher level abstraction? Because the Java provides the blocking queue implementation, which has the put and the take method. The first code that we have seen is actually building the foundation for you. The second code and the third code is just going to give you a glimpse of what's happening in the real world. Just to give you an idea that you have to understand the foundation. Otherwise, when you have to write or implement your own custom blocking queue, you will not be able to. Hi everyone, welcome to my channel Code with Ease by Varsha. We have been doing a playlist on core Java interview questions lately. So these are the many different topics that we have covered so far. Separately, we are doing a playlist on multi-threading also, where we have separately covered concepts only related to threads and concurrency and concurrent collections. Then we have a threads coding playlist where we have covered with code along with the code demo. What are the questions that comes around threads and concurrency? Today's video is going to be a mix and match of code, theory, concepts, also from interview perspective. Today's problem about the classic synchronization problem, which is called the producer-consumer problem. Very, very important from interview perspective. And not only that, it is the underlying pattern behind many of the industry standard tools and technologies that we use. We'll come to that. We'll cover all of that slowly. Let's begin. Producer-consumer problem in Java. This is going to be the part 1 of the video. So what are the things we will cover today? We will talk about who are the entities, what is involved in this problem, what is the problem about, the edge cases, the constraints, what is the importance of this problem from real world perspective, and finally we'll wrap up with a code demo. First of all, who are the main entities? Like what are the stakeholders or the important components behind this problem? As the name suggests, we have a producer and we have a consumer. Like I said, data exchange medium. Like I said, anything and everything around us deals with data. That is the core aspect. Somebody is producing that data and somebody is consuming that data. I am uploading a picture. I am a producer. My friend who is seeing the picture is a consumer. Okay. So in between, there is a buffer. There is a shared buffer. Okay. When you go to a supermarket, you have an inventory. So what is that inventory consisting of? Your fruits, vegetables, groceries, dairy, all of that. Somebody is coming to the supermarket as a producer, as a supplier who is producing those things, and that is why we call fresh produce, and putting those in your inventory. We as the customers are the consumers. We go to that supermarket as the consumer to purchase those products. So the producer on this, you can imagine somebody who is producing the data. Consumer who is waiting for the producer to produce the data so that they can consume it. Similarly, producer also cannot unnecessarily keep on producing data until it has been consumed. So we are having these three entities, the producer, the consumer, the buffer. Now the producer is adding items to the buffer, like I said, and the consumer is trying to consume it. As a result of this, the items are being removed from the buffer. This is the basic picture of how this problem, like who are the main entities of this problem. So what is this problem about? Like I said, a classic multi-threading synchronization problem, where it involves two types of processes, a producer and a consumer, who are sharing a common fixed size buffer. So as we said, producers will produce the item, they'll add to the buffer, and consumers will consume the item and remove the items from the buffer. What is the challenge behind this? The challenge is both of them have to work in a synchronized manner without causing any race conditions or deadlock. This is the technical thing. Imagine from the supermarket inventory perspective. Your supermarket, the supplier who is producing the items for your inventory, they cannot keep on producing items if there are no customers coming to your supermarket to buy those. What will happen? There will be an overflow. Similarly, your customers will not walk into your supermarket if your inventory is empty. So how will the customers buy anything if there is nothing available in the inventory? How will the supplier keep on supplying items if there are no consumers? This is the basic, from the scratch, this is the basic thing which you have to understand, the most fundamental thing. The next thing is what we want to talk about. So next we want to talk about what are the edge cases. Everything has a challenge, and that is why we are here to solve a certain problem. What problem are we trying to solve? There must be some problems, some challenges. Like I said, empty buffer. If the buffer is initially empty, consumer will not be able to remove any item. They should not attempt to remove the item even before the producer has added it. The consumer has to wait for the producer. Full buffer, like I said, supplier cannot unnecessarily keep on adding to the buffer if there is no consumer. Once the buffer is full, the producers should not attempt to add the items. There has to be a certain limit. That is why we are saying from the beginning fixed size buffer. The inventory has a fixed size of 100 items. If you try to produce 101th item or 102 item, if you produce more than 100 items, your inventory will be overflow, like stock full. I cannot keep anything. That is the full buffer. These two things. Next is uneven producer consumer speed. When producer consumer are trying to operate at different speed, producers should not overwrite unconsumed items. So this is also important, and consumer should not attempt to consume from empty slots. Okay. So what does this uneven speed mean? This is the synchronization problem. Like it should be a well coordinated effort. So the major question, why is this problem so relevant? How does it apply to our real world industry use cases? Job scheduling algorithm, task queues are used, where worker threads acts as consumer, fetch tasks from queues. Okay, let's not go into so much of jargon. Simple stuff. You have a website. Okay, there's a web server. There's a lot of incoming requests, day in and out. And then on the other hand, you have worker threads, the consumers. So all the requests that is coming, this web server alone cannot handle it. It will delegate the request to the different worker threads. So how can we think of it? All the requests that is coming is being stored in a queue. We know a queue. All of this gets stored in a queue, like in a certain lineup, okay, and a certain order that has to be ordered. Also, you cannot have a mix of different requests. So it has to be put inside the queue. These consumers on the right hand side, the worker threads, will act as the consumer who will fetch the tasks from this queue and process it accordingly. So this is the basic thing, like we already see in a real world. Tools, if we talk about technologies, Kafka. In AWS, you have something called Kinesis. You have something called SQS, Simple Queuing Service, Simple Queue Service, sorry. So they're also built on the producer consumer model, where the producers are trying to publish the events, any kind of event-based system where your user is trying to click or it is trying to do some activity on the page. Those are captured as events. There are consumers which are built. On the other hand, they just subscribe to those topics. Okay, and what happens is based on what event has happened, they try to process it and take some business decisions. Then you have messaging queues. RabbitMQ, Kafka are very popular names in the industry. They also follow the same pattern. Finally, printing jobs. So I'm sure many of you might have used a common printer in an office or in a school, college. So what happens is all the jobs, whenever you click on print, all of this then gets queued up. Okay. So whoever has given the first print command, it's like a FIFO queue, will have the first printout generated. Whenever you see the printouts being piled up, it will be in the FIFO order. So how it happens? All of that gets queued up in the internal queue, and then the print spooler, whoever is the consumer, they will get the jobs from the queue and try to send them to the printer for processing. All of them gets queued up in some common buffer, and then from there it starts get processing and goes to the printer for actual printing. So these are some of the real world things that we see around us where this producer consumer pattern is being implemented. Now let's talk about what are the possible solutions to this producer consumer problem. So using threads, what we will talk about is we will use wait and notify methods as part of this example. So these methods are called the low level synchronization construct. What does it mean? Low level synchronization construct. It simply means that when you yourself have to write the entire code to do the manual management of the producer consumer threads, like how the producer is actually going to produce the items, how the consumer should actually consume the items from the queue, how they should signal each other, how the coordination will happen. All of that is the manual management which you yourself are writing the code for. So using wait and notify is one such example. So that is why they're called low level, because they're like the lowest level of implementation. You yourself do it. You yourself write the code for that. Apart from that, Java also has a lock interface, which helps us in creating lock objects to do the same thing. And then there is also semaphores that we use. So these are all the low-level synchronization construct, which we don't really use in real world. What we use in real world, we use blocking queue. Most of the questions are also centered around blocking queue, which is the higher level abstraction. Why is it a higher level abstraction? Because the Java provides the blocking queue implementation, which has the put and the take method. The put method is being used by the producer thread, how the producer is going to use, how they're going to produce the items. So the implementation of the put and take method is already done. We just have to make use of this method. But in the first example over here, we ourselves had to write how the put method will work, or whatever name you can give, how the take method can work in case of a consumer. So that is the difference. Next is using the executive framework. So now it is no longer about one producer thread and one consumer thread management, which we so far will be doing with maybe the wait and notify methods we will write, and we will write the implementation of the put and take method, or we will use the blocking queue. So it is no longer about the management of one consumer thread or just one producer thread. In real world, you will have to be managing multiple producers, multiple consumers. And for doing that, we would need an executive framework which will help us in streamlining the thread creation and the disposal. So we will use thread pools, and then over there we will club these two concepts. So we are basically going to club the high level abstraction of the blocking queue. There are several different implementation like array blocking queue, we have linked blocking queue. So this blocking queue implementation which we will use, wherein we will already have access to the put and the take method. Apart from that, the executive framework is going to help us with the thread pools that we need to manage the multiple threads that we need to spawn for producer threads and for consumer threads. Multiple producers and multiple consumers, the one which we are actually concerned about in real world, all of that will be done by doing an amalgamation of blocking queue and the executive framework. So these two will be from the real world perspective. This one is going to be from the foundation perspective. First, you should know how using wait and notify we write the implementation. Then we use the blocking queue to do an abstraction over whatever we have written over here. And thirdly, we will see how the multiple producers and consumers work when we use the thread pool implementation. So let's see one by one the code for each of them. So moving to the first approach using wait and notify. So how will it be? First, we have a queue over here, the shared buffer that we have talked about. Okay, we have the buffer, first thing. Second is the max size. So what is the size of the buffer at a time? Let's say 5 items only it can hold. Now we have defined the producer thread. So this entire thing that you're seeing, this logic is for creating the producer thread. See how lengthy this code is. So here we have tried to write all the logic that the producer has to do. What are the things we are doing? First, we have a loop where like 10 times we have just trying to say that the producer will try to produce item 10 times. We have the synchronized block where we are trying to hold the lock, because of course for avoiding race conditions we will have to do this. We have to hold the lock, and then we have this check. Remember, this check was about the overflow. If your buffer size has already reached the size of 5, you of course do not want to put items into your buffer. So when in that case we will just print out that the buffer is full. So the producer thread will be waiting. This was the edge case which we talked about. When it is waiting, how it is waiting? It's using the wait method. Why? Because it has to release this particular object on which it is holding the lock on. On which object it is holding the lock? The buffer. Why is it holding the lock on the buffer? Because the consumer thread has to consume from that, right? It cannot be that only the producer thread is producing, and then the consumer will keep on only consuming. It has to be well coordinated effort. The producer will produce, let's say, 2 items, the consumer will produce 1 item. I'm just saying arbitrarily, it's not like always 2 items and 1 item. I'm just saying that it should be a well coordinated effort. The lock has to be released by the producer. Otherwise, it can cause a scenario called as busy waiting or busy spin, where you as a producer don't release the lock. You are waiting. So when you as a producer know that the buffer is full and you cannot really produce an item, but you yourself also don't want to release the lock, what will happen? You will kept on waiting because the buffer is full. The consumer will never get a chance to consume the rest of the items from the buffer and make the buffer empty for you so that you produce again the items. So that is the busy wait or the busy spin condition, and that is the reason why this part is so very crucial. The writing, the implementation of this, all these things are important. You must have the lock, you must have the while condition, and then you must release the lock by calling the wait method. So this is about that part. Now coming to the actual producing part, where you now add an item to the buffer, because if your buffer is available and there is a space, you want to add items. So you'll produce, you just add it, you just say produced this particular item, and then just to simulate some work, we have just done a little bit of sleep of 3 seconds. Then we have done a notify all. Now this is also important. If you have produced an item and you don't want to notify the consumer thread, it is possible that the consumer thread is actually waiting for a notification. Why? Because the consumer might be thinking that the buffer is not empty. Why? Because the consumer will also be in a state probably where we have talked about the underflow state, right? So let's come to that. Let's hold on for a bit. Let's see the code for producer. Let's see the code for consumer. See, here the same thing. We have a consumer thread, for loop, lock. Here, the main thing is, the important thing is the while loop. We will say that if the buffer is empty, I cannot consume. So same thing, I'm just going to put this into a loop and we'll say buffer is empty. So I'm waiting. Who is waiting? The consumer is waiting and releasing the lock. Now think of this. Why this notify all was important? So now the condition is, if the buffer is empty, the consumer will be waiting because it knows that the buffer is empty and it cannot really consume anything. If the notify all was not present, then it will obviously keep on checking that and it will see that the buffer is empty and it will keep on in a waiting. How does the notify and the notify all or the wait method work? We know that we have already seen that in the previous video on wait, notify and notify all, that whenever a thread is waiting, it would need a notification to be able to wake up from its waiting state. So when the consumer was in a wake up state and it knows that the buffer is empty and there is nothing to consume from, it would need a notification after the very first item has been put into the empty queue. That producer will say that, hey, I have put an item, time for you to consume. So that is why this notify all is nothing but a signal to the consumer thread that they can now wake up. So this is what the synchronization, or this is what the coordination is important, which we are writing the code for. The manual management which we are doing, how we are helping the producer and the consumer thread using the wait and the notify all, or notify, because it's single thread, so notify and notify all won't make a difference. So how we are helping both the threads to do the consuming and the producing. After that, coming to this part where it will not see the buffer is empty, where it will have items available. Now it is going to try to remove the item or take the item in or consume the item and go into some sleep and do a notify all again. Now here, this notify all is nothing but a signal to the producer thread. Now think of it like this. The buffer is full and the producer thread is waiting. But when the consumer has consumed the last item, it will send a notification that, hey, I am done. Now when it says that it is done, only then the producer thread will keep on producing. Otherwise, it would have assumed that the buffer is full. It never received a notification from the consumer. So it's like, this is a well-coordinated effort. Both of them are complementing each other. Both of them are helping each other. And we ourselves had to write the code for doing this. Now moving to the next part, the next approach, in which we will see how the blocking queue implementation is being used, and it will reduce significantly the number of lines of code that we have written. I would also like to show a working demonstration of this code that we have just seen using the wait and notify and how it is behaving. So let's move to the IDE. This is the code for this. Let's run this and see how it works. So we have produced an item, produced 0, produced 1. So this is nothing but the item number, like 0th, 0 item and then the first item. Now since 0 was produced first, FIFO queue, consumed is also 0, then consumed is 1. So in the order in which it was put, it is being consumed. So from this, now the loop has ended. So from this, since there was significant amount of sleep times in between, so we see that the buffer is empty. This message has come from the consumer thread couple of times. So whenever the consumer thread was not able to see any items, it was not able to consume any items. So this is a well coordinated effort. Every time you run this code, it is going to be different for you all. Okay. So the reason why I wanted to also show the code, just to see how it behaves. The code and all will be available in the GitHub. The link is going to be in the description, so please don't worry about that. Now let's focus only on the understanding of the code, of how the code is working, because writing a code is not a problem. Understanding the code, reading between the lines is important. Let's move on to the second approach. So now we will use the second approach using the blocking queue. So blocking queue implementation, it's an interface that we have, and there are several implementation: array blocking queue, linked blocking queue. There's something called priority blocking queue. Not recalling the name to be precise. So anyway, let's come to this. What is it doing? It has a blocking queue, array blocking queue. Here the parameter is 5, the max size that we have already given. So we are passing in this parameter. I'll show the class in a while. So here that max size declaration, all of that, that is done. It's a high level abstraction. So we are going to use this class and we are going to use the methods of this. So now see the code of the producer. So as we can see, both the codes have reduced significantly, right? The producer thread and the consumer thread. We don't have to do that manual management, all of that. Now what we are doing, we are running this for loop. Then we are saying we are just putting that item into that buffer, and then we are just printing it out, and then we are sleeping for some time. That's it. This put method is going to handle all of that. It is going to acquire the lock. It is going to check for that overflow condition. It is going to do that wait method call. After adding the item, it is going to do the notify. Everything is handled behind the scenes, and that is the reason why this is called the higher level abstraction. It's completely abstracted from us. If you see both the code, the previous code and the current code, you will be able to understand. So that is why the blocking queue implementation is simpler, and that is what is widely being used in the industry. But also the trick is, if I talk about interview questions, the trick problem will be you will not be allowed to use this built-in class. You will be said that implement your custom blocking queue. So you have to write something like blocking queue buffer equal to new custom blocking queue or my custom blocking queue implementation, something like that. So basically all the things that is happening behind the scenes, you will have to write it on your own in a class, write the methods, and then use those methods in the code. Now, if you guys are interested in seeing that implementation, writing the code from scratch, please comment down below. I'm going to make a detailed video on writing your own implementation. So as of now, we are making use of this and making the code simple, concise, readable, right? So that is what you will be asked to write your own blocking to implementation in the interview. But of course, in real world, you will not be. And also this is the reason why I said that the previous code, the first code that we have seen is actually building the foundation for you. The second code and the third code is just going to give you a glimpse of what's happening in the real world. But the actual learning will happen only if you write and understand and know the code, the first code, using the wait and notify. Of course, it can be solved using locks also and other different construct. But just to give you an idea that you have to understand the foundation. Otherwise, when you have to write or implement your own custom blocking queue, you will not be able to. That is the importance of this particular question. Okay, so now let's go to the IDE and see when we substitute with the array blocking queue, how it works now. Of course, the functionality is going to be same, but let's just go to the IDE and see the class also. So here's the code for this, and here is the blocking queue interface. So let's take a look at this array blocking queue class. So we see that this takes in a parameter, which is the capacity, and it has different other constructors also. So let's go to the put method. So here it says that it inserts a specified element at the tail of this queue, and it will wait for the space to become available if the queue is full. So you see there's a while loop where it is trying to check for that condition, and if it is full, it is going to use the await. So this is the implementation, the behind the scenes implementation which we have seen. We were actually writing the code, we were acquiring the lock, checking the edge cases, doing the wait, and now here we are seeing that how it is actually being done by the built-in class and the built-in methods, and we just have to make use of this, and that is what we are making use of it. So if I run this particular program, we should ideally be seeing the same output. It's just that the code is much more readable now, and we have hidden away, we have abstracted most of the underlying mechanism of what it is happening. So now moving to the next approach, which is the multiple producers and multiple consumers. So now let's wrap up the final segment for today's video, the multiple producer and consumer. Let's see the code for this. So over here, nothing much. We have the same implementation. The only new thing will be the thread pool. If you do not know about thread pool, I have a dedicated video on that in the threads and concurrency playlist. So please check it out. The link of the playlist is in the description. Now the producer and the consumer thread, since it is multiple now, like two producer, two consumers, in contrary to what we have seen, like one producer and one consumer. So now the threads will be created as part of this thread pool. So implementation wise, the only difference is we have multiple producers now. Otherwise, we are making use of the same put method of the blocking queue. And one small tweak of logic which we have done is we have two producers, P1 and P2. So let's say P1 is now going to produce the range of values in 101 to 104, and P2 is going to produce in the range of 201 to 204. So I've just written this small method just to do a distinction of what are the values which the two producers are producing. And if you see the consumer code, it is also same, the blocking queue implementation, and it is just going to consume from the queue and some sleep in between. So pretty much the same logic, because it is the code of the producer and the consumer, which is going to stay put. It is going to stay constant. Only thing which is going to change is how many producers are going to be spawned and how many consumers are going to be spawned and how they are going to be handled, which is handled by the executors itself, the executor interface itself, the executor framework itself. That is the thread pool that we discussed. So now let's go to the IntelliJ and try to see what happens when we run this. The producer implementation. This is the code that we were just now seeing. Let me run this. So we see that first there are two producers, producer 1 and 2. The producer 1 is producing in the range of 100 and then 101, and it is going up till 104, and producer 2 is producing in the range of 201 to 204. Similarly, now the consumers do not know, right? Now consumers are just consuming what is there on the queue. So if producer 2 has produced 200 and then producer 1 has produced 100, we see that consumer 2 has consumed 200, which is put before, and then consumer 1 has consumed 100, and then this goes on. Now the order is not constant, it is going to change, but the idea over here is, of course, this is not the exact real world code. There's a lot of business logic and a lot of other things involved. And then what we try to bring out, the main thing which we need to emphasize over here is how actually, with the help of blocking queue and with the help of thread pool, we can try to recreate this multiple producer and multiple consumer scenario. And this is just going to give you a basic understanding of how it works. Yeah, so that is all about today's session on producer consumer. I hope you guys have got some value out of it. The code will be available in the GitHub. The link is in the description. Please check it out. Thank you so much for watching this video. Do hit the like button if you like the content and share it among your friends and peers. And you can let us know in the comment if you want a part 2 of this particular series on producer consumer. Thank you so much for watching.